Hi, it's Jan Beta, and by popular demand, well, at least 3 people in the comments demanded it, and I want to do it as well. So we are going to take another look at another Commodore 64 EPROM programmer, the Merlin PP64, which is very similar and I think compatible to the Promenade EPROM programmer, which was more common in the US, I think. This is a German product, but it's derived from that, I believe. So we're going to take a closer look at that, and then I have a little piece of software that I made or hacked together that solves one of the problems I had in the previous EPROM programming episode that I did. Yeah, let's take a look. In the last episode, I encountered the problem that the old-style EPROM programmers on the actual C64 are not compatible with modern-day binaries that you just download from the internet, like kernel ROMs or cartridge ROMs or things like that, that you can find on websites. And that is because the Commodore 64 side of things expects to see 2 bytes at the beginning of a file that contain the start address in memory. 2 bytes that tell the computer where to load the program in memory. And that's standardized in the Commodore DOS, basically, the disk operating system. So whenever you save a program file on a C64, which is the format that the EPROM programmers demand, basically, programs, you can save data files without the 2 bytes and things like that. But program files always have 2 bytes at the start that tell the system where the program should be located in memory after loading. And there's no workaround for that, really. And of course, the modern binary files that were mostly read with more modern EPROM programmers, most of them don't have these 2 bytes, so they are going to be burned wrongly on the C64, because most EPROM programmer software has 2 options: either use the start address in the program file to actually locate the program, or just ignore the 2 bytes, in which case they just cut off and the program then starts at a wrong command in the middle of the program after 2 bytes, basically. So it won't work with a modern file. That's what I figured out, and there's no way around that in Commodore DOS, because that's the standard thing that it just does whenever you save a program. To work around that, I used a hex editor and just inserted 2 bytes of zeros in front of my file that I wanted to burn, and that worked fine. But I thought it would be really cool, if pretty useless, to be able to do the same operation on a C64. And I think I found a solution. I already tested this briefly. It's kind of beta software, as my name suggests. I quickly hacked this together in BASIC, and yeah, it's not very polished, but I think it does work, and I'm probably going to work on this a bit more. So I present to you at 2 bytes my little basic workaround for that exact problem. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding, basically everything the tinkerer needs. And they are currently celebrating their 12th anniversary, so all through July you are going to get some nice discounts and coupons, and some special PCB colors are free upgrades for that time, which includes pink, purple and matte black, I think. So I highly recommend checking out the link in the video description if you're interested. Back to our EPROM shenanigans. So as I said, I haven't extensively tested this, but yeah, this is a little basic program. It's 4 blocks on a disk. Very small, because it just makes use of some DOS commands that we're going to have a look at the code briefly in a second. Basically, this just adds 2 bytes at the start of the input file to make it usable with elderly EPROM burners. The result is saved in a new file. So you can input a the file name of the file, the binary that you downloaded from the internet, and you transfer it to your C64 with some modern device, probably SD2IEC, or in this case 1541 Ultimate, Pi 1541, Backbit cartridge, Kung Fu flash. There are many options to do this nowadays, to just transfer files from your modern day PC to a C64. The output file name, we can't, I did some error handling in this, so you can't input the same file name. And yeah, then you just hit return. It asks you to insert the disk with the files, or with the file. And then it creates a little file. And it fails in this case because it can't find the input file. So I did some error handling in this. This dummy file that I'm generating is a bit of a workaround, but it's the only way I could think of that makes it possible to do this in Commodore DOS without even using too much of the internal RAM. So you can, in theory, use this program with larger files that are larger than the internal memory of the C64, which, as you probably know, is 64K. So let's take a look at the code. It's pretty crude, I warn you. I'm not the best programmer in the world, but yeah, it's just going to be a brief look at the code here. Line 10, I'm just changing the background color and the border color to black and purple, because I like those colors. This is just the text printed that we've seen. Then we're inputting the name of the input file. And you can enter Q to quit, or you can just hit return and it's going to quit. Go to 280 is just, the line basically just says end. Just put it into an extra line to make it easier to work on this program, because I changed this quite a bit. Then it inputs the output file name into a variable, and if they are both the same, this of course won't work. It can't overwrite files. You could also code that in and delete the old file and things like that, but I didn't want to do that. Can't overwrite files. It presents you with a little error message. Then it asks you to insert a disk. Line 140, it waits for a key press, changes the border color again, and says creating dummy file. And now it creates a file that's just a file that's named Q, which I find pretty clever, because Q is the command for quit, so you can't accidentally enter Q as your file name. If there's a file that's named Q on the disk you're using this on, this is not going to work. But chances are pretty slim. I know this is not the best error handling. So if you're using this on a disk that has a file named Q on it, it won't work. Didn't catch that error in the code because it was very quickly hacked together, as you can probably see. Yeah, but this just prints one character number 0 into the file, basically. It opens a file named Q, prints one character into a file, and that's 1 byte. The reason for only printing one character, took me a while to figure this out, is that if you do it like that, if you make a file like that, it is going to make a file that consists of the things you print into it and the enter code, which is 13, I think, character 13. That's always in there. I couldn't find a way to work around that, so I'm only printing one character, which makes it 2 bytes in total. And then I'm closing the file. Go sub 1000 is the disk error handling. I made a little subroutine for that, which I'm going to show you in a bit. And now comes the magic. This is the command I found. You can actually merge files together. So I'm using my dummy file. This is the C command that I'm sending to my disk drive. This should work on all Commodore 8-bit disk drives, by the way, because the DOS is similar. I'm not sure if it does. I tested it on a 1541 and it works fine, but it should work on all the Commodore drives, basically. So I'm sending the C command, which makes the output file, and that is the Q file, plus the old file, the input file. I'm adding the input file to my dummy file, basically. So it's 2 bytes, and then I'm adding the input file. That's all that it does. And then I'm closing this again. This takes a while, depending on the file size, of course, but it's all done inside the drive, so it shouldn't be really RAM intensive or anything like that. Changing the border color, checking the error code, and then I'm, of course, have to delete the dummy file again. This is the DOS command for deleting that. Scratch S in this case. We're basically opening a channel to the drive and then doing all these commands. I'm closing this every time basically because I had some hiccups with the program crashing without the close. So yeah, you can't really send more than one command. And for some of these, I'm not sure if that's a bug in the DOS, but probably somebody knows. I'm not the most proficient in Commodore DOS. Yeah. Then it prints success and sets the border color to green. If it was a success, whenever there's an error, it should set the border color to red. That's to make it easier to see if things were successful. And then I'm doing this, which is a reset of the drive, basically. So we're initializing the drive, which for some reason is necessary to use the drive after running this program, which was also an error I encountered. It should not really be necessary to reset it, because we're closing everything and things should be back to normal, but it is not even possible to save a program if you did these commands here. So I'm resetting the drive and then the program ends. And this is the little subroutine for checking the error state of the disk drive. That's just, again, opening a channel and inputting the state of the drive. That's 4 variables basically, and then it closes the channel again. And in case there's no error, the first numbers are 0, 0. In this case, I'm reading this as a string variable because it looks neater. You can also read this as a number. So it's a number, then the error message, and then 2 other numbers that I think relate to the error or where it occurred. If everything is all right, error is 0, then it just returns to where it called the subroutine. And if it's different than 0, it's printing disk error in red, sets the border color to red, and yeah, it then deletes the Q file again and resets the drive again. I had to do this. It's a bit hacky, but yeah. If there was a file generated and then it encounters an error, this is going to make sure that your disk looks the same as before you started the program. And that's basically it. So this actually is a bit bloated for what it does, but I wanted some relatively proper error handling in there, at least. So yeah, I think we are going to test this program actually today and burn an EPROM with our Merlin EPROM programmer. And by the way, this is not vibe coded. This is just my poor programming, as you can see by me just explaining every single line. Basically, it's my handwriting, my hand coding, if you will. And I'm going to put this up for download in the video description in case you're interested. I think it's pretty useful. I just haven't tested this extensively, so use this at your own risk. Change it, whatever you like, just leave my credits in there. That would be nice. This is free, as in open source. Basic programs are open source by design, I guess. And you can do whatever you want with this, but don't feed it into your AI. Let's find something that we can program with the other EPROM programmer. Probably going to make a cartridge that is somewhat useful to me. And I think for our ROM to test our program on, the most useful thing that I can think of at the moment is the DESTestMAX. That's from Matt Desmond, Factor of Matt. I'm going to link that in the video description. A very in-depth, proper RAM test for the Commodore 64. And there's also a better version that needs a cartridge, a special cartridge PCB, which I didn't order yet, but I'm going to build that at some point. You can also buy the cartridges pre-made now, it seems. But I'm just going to go with the standard version, basically, that I already have an older version of. There's also a kernel version of that. That might be useful for some stuff. But I'm going to download the regular version now and just put that in a cartridge after burning it. And I'm going to put that on my disk, basically. And yeah, this is pretty basic stuff. I just download the file and put it on my USB stick that I'm going to use on the C64. That's why I'm not showing the screen in detail here. But definitely check out the DESTestMAX cartridge if you are interested in C64 repair. So back on the good old C64, we are going to use the 1541 Ultimate to just copy the file into our disk image, basically. I'm just going to hit the Commodore key and C for copy. And then we can just go into our disk file and paste it with Commodore V. And there we are. Now it should be on our disk file. And we can mount the disk. So we now have our DESTestMAX file on here. That's a regular program file. That's exactly what we need for our ADD2BYTES program, which I'm going to start now. And it's DESTestMAX. That's our input file. And I'm just going to DESTest2B with 2 bytes added. Insert the disk. We have done that virtually. It's creating the dummy file. Takes a while. And this is the thing that takes a bit longer because it's reading the whole file, the input file, and then saving the whole file basically at the same time. That's why I put a little please wait in there. But it shouldn't be too long. And hopefully this is going to work. Otherwise this whole program is useless. Even more useless than it is. Probably 3 people in the world are going to find this useful. It's deleting the dummy file, and it says success, and the border turned to green, just as I imagined. So we should have an additional file on here now. Yeah, DESTest2B, and that's the file we actually want to burn on our EPROM programmer. So let's try that. And this file now should have 2 bytes additionally at the start of the file, and it should start at the start address 0D00 because we wrote 10, and then Commodore DOS adds the return command basically, which is 13 or 0D in hexadecimal. And yeah, that's a relatively sensible start address, I think. But of course, yeah, if we load it, we should see that, exactly that. Yeah, 0D00 to 2D00. That's not a bad place to put things in memory, actually, because usually the programming software and things like that are pretty small. So this might even work if you use the address that's in the file. But it is recommended to use the recommended address to load stuff in the EPROM software. So this is just kind of a workaround, as I said, because I can't get rid of the return code there, 0D. And yeah, this is also reversed. So the first byte is the second byte. The first byte in the file is the second byte in the load address. So we have 00 in the end of this load address and 0D at the start. Yeah. Bit complicated, but yeah, that's what it does, and the program seems to work fine, as I said. So This file should be totally programmable into an EPROM now. Let's try with the Promenade/Merlin EPROM Programmer. Yeah, this is the device itself, and if you bought this back in the day, it came with a cartridge, which is interestingly potted in this yellowish resin, which is actually how these looked when you bought them. Because Merlin, the company who made these, I found an article about this a review when it came out, and they decided that some of the new C64 cases would be too tight for the cartridge cases, the shells that were actually available at the time, so they decided to do it this way, which of course, in hindsight, makes this impossible to service. Yeah, it also probably makes this impossible to reverse engineer. It is working. This cartridge starts the Merlin software. However, I'm not going to use that yet. We're going to use that at a later point. I am going to try to use the software that came with the Promenade EPROM Programmer, which in theory should be the exact same as this. At least from a software point of view, it should be the same commands that control this. This is probably a bit updated to the Promenade because it came out a bit later, I think a year or two later than the Promenade was available. And the Promenade also had a metal case. So if you have one of those, all the things that apply to this should also apply to yours. When I researched this a bit, I also found that there's a modern recreation of the Promenade EPROMer by Sven Petersen, who contributed so many things to the retro community, especially the C64 and VIC-20 community. Thank you, Sven. I'm going to link the GitHub where a recreation of this is available that I don't think was tested in depth, but it should be working, I guess. A recreation of the Promenade EPROMer is in there, and you can make your own if you so desire and try it, but try it at your own risk because it wasn't tested, as is clearly stated in the GitHub. I'm going to try to use the software for the Promenade now to maybe verify that this is compatible with that. And then later we're going to use this. As you've seen, I have my 1541 Ultimate currently in the cartridge port, so I can't really use this. At this point, we need a real drive for that. But we can use this with the Promenade software. So we're going to insert this into the user port, as with the other EPROM programmer. Same rules apply, basically. Don't insert an EPROM before you have started the software, because it might output a voltage on the EPROM socket and ruin your EPROM, which we, of course, don't want. And I found two versions of the software for the Promenade. One is the original version, that's the Promenade. That is basically a command line interface that is a bit more complicated, but I think it's the same command line interface that the Merlin software has, where you have like a machine language monitor and things like that, where you can basically add the 2 bytes. With that, I'm just going the easier route here with my little program that I made to add the 2 bytes. You can, in theory, just load the program into a machine language monitor on your C64 and just save 2 bytes more at the start of the program. Yeah, this is the command line interface, basically. Prom OS is what it's called. And there's also a Promenade 8 here. That's interesting. That's probably a more friendly user interface. If you find this program useful, send donation to Clingware Shareware. This is a shareware program. Interesting. Yeah, I found all these programs I'm showing here that are for the Promenade EPROM Programmer. I found on the website from Greg, who made the C64 OS. I'm going to link that in the video description as well. He wrote a brilliant article about the Promenade EPROMer, and I think he also initiated the replica by Sven Petersen. Scroll through EPROM types, plus and minus. That's pretty nice, actually. Pretty neat. I like this. That looks way better than the other user interfaces that we've seen. And it can do the same: load and save to disk, read EPROM, program EPROM, verify erase, create cartridge, break to monitor. It also has a built-in machine language monitor. That's a nice user interface. And then we have the normal interface, which looks like this. It just says PROM OS 2.0. This is from 1988. I think the initial version is much earlier than that. And this has commands where you can do the same that you can do with the graphical user interface, basically. I'm probably not going to use this because we have better stuff. And Promenade 8 was what I started before. But then there is PROM Shell, which also looked pretty good. That one I already tried. That has a kernel modifier on there and things like that. Wow, so many things to try. Yeah, this basically uses the PROM shell that we've seen before and then boots a graphical user interface. Or graphical is a bit of a stretch, but yeah, this looks like this. And that's from 1997. Ben Holmes made this, it seems. And we can scroll through the EPROM types here just as we did on the other one. It has the same functions, basically. A nice rainbow animated stripe there. So this is another version of the software, basically. And later on, we're also going to look at the Merlin version of this. These can all do the same. They're working with the same hardware. So it's just a matter of taste, basically. And I guess all these work the same internally because they're just using the PROM OS, basically. And the same for the Merlin program, which also has the same command line interface, I think, integrated in the cartridge. Yes, so which one should I use? So I'm just going to use the other graphical user interface for the Promenade, I think. Promenade 8. That looked slightly more sophisticated. Just going to select my EPROM type, 2764A. Yeah, should be the correct one. The programmer shows a green LED now. It showed all the LEDs lighting up when I started the program. So it definitely puts voltage into the socket there. So you don't want to insert your EPROM too quickly. So yeah, just going to insert my disk with my program again. L for load program. DESTestMAX. That takes a while, of course. Yeah, now it says file in memory DESTestMAX. So I can insert my EPROM. It doesn't even tell me the start address and things like that. So this ignores the first 2 bytes, it seems. Yeah, let's program the EPROM. Or let's verify erase. E. Insert EPROM. Hit key when ready. Remove EPROM. Check error light. No error light. So I assume it would show me a yellow LED here. There are 3 LEDs on here. Green, it shows green, so probably this is blank. Okay, let's program the EPROM. P, program number. I'm just going to put 1 and hope for the best. I'm not sure what this does. Illegal program for this type. Okay. Standard program is NR. I'm just going to put this into NR because it says so here. Let's see if that does something. Insert EPROM. Okay, I did. Remove EPROM. Check error light. Yeah, and indeed, my error light is flashing. Remove EPROM. That's not good. I have another 12.5 EPROM. That's an even older EPROM this time. Let's see if that does anything. Throws me an error. Oh, you know what? Maybe we did something horribly wrong the whole time. And that is that there is a little switch here that can program low and high memory banks. So I'm going to look at the manual, actually. You know what? I'm just going to try to switch this in the other direction. Yeah, it's now programming the EPROM. That should take a while probably. We just had the little switch in the wrong position. And the manual for the Merlin that I have here printed out doesn't say anything about the switch that I could find. But it's for programming low and high memory regions of the EPROM when you have a larger EPROM. So you program the banks in the EPROM individually. You do one pass with the switch in one position and then the other pass with the switch in the other position. Now it's programming away quite happily, it seems. And it's all lit. We don't have any progress bar or anything like that, but the LEDs are lit. So I assume, there we are. It finished, I think. And it says on the screen again, remove EPROM, check error light, hit key. Okay, I'm going to do that, just that, no error light. So this should be our DESTestMAX, I think. I took a bit of a shortcut and just read the EPROM with my modern EPROM programmer. That actually looks pretty good. Let's see what the file looks like. Looks the same to me. Verify. Yeah, it worked. So this should be a working cartridge ROM, EPROM now. Okay, EPROM. No bent pins. So let's see what we got. Got the cartridge in there. I had to correct one of the jumpers. Yeah, because I didn't pay attention. But now it works. This is the new version of the DESTestMAX. But there is another version that requires a special PCB that I'm eventually going to build that can test actually all the 64 kilobytes of RAM. This is from February 2026, so this is the latest version. Nice. That worked. We programmed this with the ancient EPROM programmer, basically. It's a few days later, and I looked into making cartridge files with these EPROM programmer softwares that we tried. And unfortunately, there are very few options for making multiple program cartridges with these, unless you have special cartridge PCBs that were sold at the time for the different EPROM programmers. And those allowed for having multiple programs on them and even adding programs later on. So you could use the Promenade shell, for example, to program more programs on an EPROM that was already programmed after you programmed a bunch of programs on there already. So that is pretty cool, but I don't have the cartridges to try. The cartridge generator things in the graphical user interfaces usually just works for a single program converted to a cartridge. That means it just adds the cartridge header, which just is the string CBM80 for Commodore cartridges, Commodore 64 cartridges at least. And then it adds a little auto-start routine that points to the start address of the actual program to make that start when you insert the cartridge and turn the system on. So that's pretty neat in itself, but there is an option in the DELA EPROMer software to make multi-load cartridges just using a regular EPROM cartridge like the ones we used before here. This is the Future Was 8-bit cartridge again. And this can take, I think, 8K EPROMs at the most. You can do bank switching on here, but it doesn't support showing more than 8K to the system. So you can have multiple programs on an EPROM on these, but you have to switch manually to the other programs. So it's basically acting like multiple EPROMs that you switch between with using multiple banks on the same EPROM. So yeah, I'm going to show you some of the softwares, and I think we're just going to make a single program EPROM, but I'm still going to show you what's possible if you have the suitable cartridge PCBs. We're going to make a cartridge with a single program, and I already have my 1541-2 disk drive out here, and I have a disk that I put some software on. So we're going even more old school than before, just using the means that we had back in the 80s. So here's the very, very old school Merlin software. And we go into the menu. And yeah, we're just going to choose a random EPROM for the moment. And there's the module generator or cartridge generator. Just going to hit G to show you how that works. And we can just load in a program. Just going to use my ADD2BYTES program as an example here. And now it loads it from disk. And yeah, basically it now has the generated cartridge in memory. And we could just program the EPROM, and we should have an auto-starting cartridge with that on there. Yeah, that's how it looks in the Merlin software. Just going to remove the cartridge now. Just going to show you what it looks like in the Promenade shell. And of course, you can use the basic extension that is also on the Merlin cartridge to work with the dedicated EPROM cartridges that Merlin offered back in the day. And the same goes for the Promenade stuff. I think this is basically doing the same thing. You can make single file EPROM cartridges from the shell variant 2764. Yeah, and now we can create a cartridge, I think. Instructions. Let's read the instructions. Yeah, this is for the PCC4 or PCC8 boards in this one. So you can use this to generate the boot EPROM, which has a piece of software on there that allows you to access the software on the other EPROM. These are two EPROM cards, I think. They have two EPROMs each. And then you can use the save programs command to save multiple programs on the other EPROM, one by one, basically. Which is kind of neat. So you basically had a writable ROM. You can't rewrite it, of course, unless you delete it again. I guess it was pretty neat back in the day, but it's relatively useless these days, I guess, because we have so many cartridges that can simulate this with media that is easier to delete and rewrite and things like that. But it's still super cool to have this. And probably I'm going to try this at one point if I can get hold of the dedicated cartridge PCBs. Yeah, that's how this works. And then we have the DELA software, which can do a bit more with regular EPROM cartridges. This is our EPROMer software. And this has a cartridge generator in the second menu, I think. Yeah. Module generator. G. And here you can choose between a normal 8 or 16K EPROM card, or EPROM card, as it says here. This software looks really shoddy, but this is actually a part that is better than for the other ones, because you can make multiple program cartridges with a regular EPROM card, which is what we have at hand. And the other thing says electronically switchable EPROM card, and this is aimed at the cartridges that DELA actually sold. They had cartridges with multiple EPROMs that you could program with this, and they are switching the bags electronically with the software that this generates. Similar to the Promenade stuff, you had an EPROM with the software and one EPROM basically with the software that controls the EPROM card. But as I said, I don't have these, at least none of them that I have. I want to change in any way. I might go back in and do that at some point. But yeah, we are choosing normal EPROM card, and we can choose between one program without a menu and multiple programs with a start menu. We're going to do more multiple programs, and we can just put my ADD2BYTES program on here, and it reads that, and it says I need an 8K EPROM at least for that. It asks me if I want to put that in the module. Yes. Then it asks me if it wants me to switch the card off if the program is in the memory location that is already used by the system. You need to switch the memory locations around. I guess we're going to say no, because it's not in this memory location. And then it asks me for the key that starts the program. I'm just going to put 1. And now it asks me if I want to end creating the cartridge or load another program. I'm just going to load another program. And we're going to load Azimuth, the program to adjust data sets, basically, that I used a lot of times. Yeah, we don't want to switch the card off because it's another basic program, and we're just going to put 2 for the Azimuth. And now we are going to end creating the cartridge, and this allows me to have a menu. So I can create a menu that is going to be displayed on screen. And I'm just going to make it very simple, but of course you could use all the Petsky stuff. Oh, misspelled my own program there. So that's what I want my menu to look like. But you could, of course, make it a bit neater, just for demonstration purposes. So now you move the cursor to this location here that says end, and I'm just going to hit enter here, or return. And now it asks me if I want to save the EPROM. Yay! And we're going to save that on disk and call it Multiload, I guess. And that takes a while, of course, because the 1541 is a bit slow. Yeah, and that should have generated a file with our 2 programs that are very small in this case. But you could, depending on which EPROM type you use, you can go, yeah, that's 17 blocks. That should fit fine on an 8K EPROM, which is around 33 blocks on the disk, as you can see here. That's the file for the DESTest cartridge. Yeah, I guess we are going to burn this using the Merlin programmer again, and then put it in a cartridge and see if it actually worked. But in theory, this should be how it works. And if you want more programs on there with the other cartridge generators, you need to have dedicated PCBs for that. There are also modern approaches to make multi-load cartridges. For example, the 64K cartridge that Hucky from the Forum 64 created, that was used in quite a few games and things that got released recently for the C64 as well. And that is exactly the kind of cartridge that you would use with these multi-load generators. And there are generator programs for that actually available, but I think it's slightly different from the cartridges that came with these EPROM programmers, or that were available for these EPROM programmers. So it's probably not going to work with this software, but you can use the other software that is available. I'm going to put a link to that in the video description as well. I'm probably going to make a dedicated video about that at some point, because this stuff is just too much fun. So sorry if you are not interested in this. I am, and it's really, really a cool experience to figure this stuff out all these years later. Yeah, let's burn our EPROM and put it in a cartridge, I guess, and see if it actually works. It's the 1541 I'm using, by the way. 1541-2 in this case. C64 with 12.5 volts EPROM programming voltage. We're going to load our program. And we're going to program our EPROM with program NR. Insert EPROM. Going to do that. Making sure it's nice and firmly in there. And hit a key when ready. Let's see if this works. Fingers crossed. Way! This is programming, as indicated by the LEDs lighting up there. And it just says programming EPROM on the screen, and this is going to take a while, as we know now. Remove EPROM, check error light, hit key. Okay, removing the EPROM, checking the arrow light, which is green, which is hopefully a good sign, and I'm hitting a key. Yay! Think we are good. We're going to find out shortly. I'm going to prepare a cartridge PCB and see if it actually loads our program menu. You want to configure these as a normal cartridge. The configuration you would use for a diagnostic cartridge with the little jumper things on here. Yeah, looking good. So these are the jumper settings. Both jumpers on the left are closed here. So in theory, that should be the setting for a regular cartridge. And we should be able to put our EPROM in. Okay, let's try it in the C64. And yeah, if everything went according to plan, we should see our start menu on the screen when I turn this on. Let's see. Nope. There we are. Just a bit of wiggling the cartridge around. Oh, I thought it would work, but it works. So here's the fancy menu that we created before. Let's try and start the programs. Add 2 bytes. I'm starting my own program from an EPROM cartridge. That's pretty cool. Nice. Yeah, and it's all there. So that works. Let's reset. And should go back into the menu. Let's see if the azimuth program also works. Not really. No, the azimuth won't start. So your mileage probably varies a bit depending on which kind of program you put on there. But in theory, this is how we did it back in the day. And this, at least, the menu works. But our azimuth correction program doesn't quite start up for some reason. I'm not sure why. Yeah, it's for demonstration purposes. I'm going to try to figure this out another time, I think. But this is how it works. So you can make cartridges, even standard cartridges that have multiple programs on them with the appropriate software, if you so desire. And of course, this makes more sense with larger programs and like the dedicated EPROM cards. But for a normal EPROM card, you can just convert your game or whatever you want to put on a cartridge with one of these programs that are shipping with the EPROM programmers. Or you can download them these days, of course. You can just use one of these. And for a single file, it should be even more compatible. I'm pretty happy with this, even though it doesn't work fully. Yeah, I think that's it for today. I showed you some of the things you can do with the Merlin EPROM Programmer. And you can basically do the same with other C64 EPROM programmers as well. The Merlin also comes with software for the VIC-20, so you can use this from your VIC-20, which is even more of an adventure given the fact that the VIC-20 has far less memory than the C64, so I'm not sure how well that works for larger EPROMs. You would have to program a lot of banks into them because they can't fit into the VIC-20's memory all at once. But for the C64, you can at least program your own kernel ROMs and cartridge ROMs and things like that without much problems. And it's really fun to do this on the machine itself with hardware and software that was available at the time. I'm having a lot of fun with this. I don't know if this is interesting to more than 3 people in the world. The software I used and things like that I'm going to link in the video description. If you already have a modern EPROM programmer, this probably doesn't make much sense from a practical point of view, but it's still a lot of fun doing this on the actual hardware and making stuff for the machine on the machine itself. It just pushes all the right buttons. For me, at least. Thank you very much for your time. Hope you enjoyed this little adventure. And there's going to be more because I am really happy about these things, as you can probably tell. Special thanks, as always, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are in the video description and on my website, in case you want to give me some support and help me buy more EPROMs, more cartridges, more C64 stuff. You make these videos possible, so thank you very much. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.